Find the tangent to normal and sketch this curve at the point 1 root 15 over 4 coordinate. So let's just sketch it first then, shall we? And then we'll do the tangent to normal, because this is the easiest thing to do. So when y is 0, put 0 in here. We'll see that x squared is 16, so x is plus or minus 4. So we've got 4 here, and minus 4. And then when x is 0, so this goes to 0, doesn't it? Y squared is plus or minus 1. So let's mark that off here and here. Minus 1 and 1. So let's try and draw it then. So here's our ellipse. Not very well drawn. I'm going to have another go at a quick go at that, if that's okay. So we've got our ellipse. A smidge better. So there's our ellipse then. And we need the point 1 root 15 over 4. So x is 1. So an up root 15 over 4. Here's our point here. So we need to draw a tangent here. So let's do that. So it'll probably be up the tangent here. Fairly shallow. I'll try and draw it here if I can. Like so. There's the tangent and then the normal, which will be up here somewhere. So I'll try and draw that here if I can. As best I can, that is. Not necessarily terribly accurate in terms of scales and values, but approximately it should give us a gist of the tangent and normal and the way they are. So let's differentiate then. Here, differentiating gives. Differentiating term by term, that is, gives 2x over 16 plus 2y times y dashed, function on function rule here. Constant goes to 0, so y dashed then is equal to minus this object. So in our mind's eye that's now over there, and then when the 2y can come down to be underneath, put a 1 on top and then 2y underneath, which is minus 2's cancel x over 16y. At the point 1 root 15 over 4, y dash then is equal to x is 1, so that's minus 1 over 16 y, which is root 15 over 4, but the 4 can swing up to the top now. The 4's will cancel, so it's minus 1 over 4 root 15 times by root 15 top and bottom if we wish to rationalize the denominator. 4 15s are 60. So it can be written as minus root 15 over 60. And now we can write the tangent. So tangent at the point is y minus the y coordinate, root 15 over 4, is equal to the gradient, which is minus root 15 over 60, quite shallow negative gradient, times x minus the x value at the point. So you can see it's a negative shallow gradient, which is what we've got in the picture here. That's good. But also, what's the constant roughly? If you move this over here, this will be plus small, plus another small, but slightly bigger. Yeah, it's going to be plus just above 1 probably, which is what we've got at. And then of course the normal, which is easy to get now. And the normal, it's going to be the identical line above for the most part. So y minus root 15 over 4 is the same, because it's the same coordinate. And the x minus 1 is okay. But these products, this needs to be 60 over root 15. Or we can write this, I'll put 60 over root 15 to avoid any confusion. Because that's a minus, this should be a plus. And that is equal to 4 root 15, isn't it, as we said before. Times x minus 1. There we go. Again, it's a positive gradient, quite steep, as this normal line shows here. So let's go back to the sketch. We're fairly happy with what we've drawn.